Okay, awesome. So today I'm going to talk about, in general, high performance computing for AI ML in the cloud, but then we're also going to talk about how to actually use specifically generative AI in the cloud. So here is the general agenda for today. I'm just going to give kind of like a 10,000 foot overview of kind of like what's going on. And then we're going to get into distributed training. Then we'll talk about accessing these foundational models, and then we'll go into general tips. And by the way, if questions come up during this session, that's totally cool too. So feel free to pose those questions as we go. So at a high level, there's kind of like three categories of what's going on. What we have is basically three categories, right? So the first category is you have your foundational model providers. These are kind of like your Anthropics of the world. They're your runways, they're your stability AIs. And there isn't many foundational model providers out there. And I don't think there probably is going to be a lot of them, as you probably know yourself. And these types of persona customers, this is where you reach super large scale, right? And typically these customers do everything on bare bones. They don't use necessarily managed services from AWS, but sometimes they may use Amazon SageMaker. And so part of this talk, I'll go into the details of like, what does that really look like? What are the pain points that these companies run into when they run such large scale? The second thing that's kind of new is these foundational models, they need fine tuning, right? Like we're gonna expect thousands of models to be created via fine tuning. And a lot of the cloud providers and companies out there, they're basically tasking themselves with making this fine-tuning process as frictionless as possible. What does that really mean? That means how do you keep your security officer happy so that data isn't leaving your own environment? It means how do you do this without necessarily having an ML engineer? And also how do you have access to good models that you're fine-tuning, right? And then finally, there's inference. This is probably the most active part of my role. Like today, a lot of Fortune 500 companies are coming to us and saying, hey, how do I build this thing using an LLM? And what models do I have access to? And what's kind of interesting about this is that it's moving really, really, really fast, right? But 6 months ago, I would have said that you shouldn't use an open source model if you're trying to build a generative AI chatbot, for example. Now, Falcon 40B is released, right? Now you can do really interesting things with Falcon 40B. So this part of the world is changing so quickly. And I'll give a little bit of talk about like what are Fortune 500 companies asking for in the context of these models. And then at a high level, most cloud providers are approaching these different layers of the stack with generally different solutions. So there's kind of like three personas. The first persona is a developer that wants to use AI without necessarily doing any ML, right? So they just want to use generative AI to power their applications. And this is basically like the OpenAI solution where you have an API. Amazon's version of this is called Amazon Bedrock, if you're curious. And so, for example, what Amazon does is we give you access to Anthropic's Claude model, AI21 Labs model, Stability AI's model, alongside our own Amazon Titan models via an API. And the API is capable of also doing fine tuning as well. So that's for that persona. The second persona that I'll talk about is your data scientist / ML engineer that wants to fine tune and deploy pre-trained foundational models, but they don't want to necessarily manage a cluster of like 1,000 GPUs, and they don't necessarily want to be an expert in HPC ML. And this is where a lot of customers may use something like SageMaker. SageMaker is basically, think of it as a pre-built environment for you to do training or inference. And then at the bottom of the stack, this is where kind of like the experts sit. This is your expert ML practitioners with expert data scientists who actually want to build their own environment to build their models. And this is where people are doing bare bones EC2 instances using hundreds of A100s, now H100s. and it's all about price performance in this case, right? It's you're gonna have every single knob to play with to optimize what you're trying to do here. So what I'm gonna first cover is building foundational models. Like, what are these folks doing? And to give you some background, in my role, I have helped. If you see any foundational model providers on AWS, chances are I work with them. So I'm sharing with you some of the insights and learnings that we've had in working with these types of customers. There's three main challenges in building foundational models today. The first thing is that GPUs are really hard to find. So that does become a part of how you go build this, right? And it isn't just finding the number of GPUs, it's finding all the right GPUs in the same spine, right? Because you want a cluster of A100s that have super fast networking today. Once you have that, then you have to start thinking about time to train and cost to train. So you really have to think about your cluster at the cluster level versus like what just happens at the GPU level. And this is what I mentioned earlier. There's really two ways to do training at AWS. There's SageMaker, and then there's basically bare bones EC2. The way to think about it is with SageMaker, it's a pre-built environment for you to train. With EC2, it's build your own environment to train. I'm going to talk about customers that build their own environment, because I think that's kind of where the interesting part is about where you see patterns about what these foundational model providers do. So when it comes to foundational model training, you really start to talk about distributed training, which is an HPC ML thing. It's high performance compute meets machine learning. And there's pretty consistent patterns that you see, right? The first thing is these foundational model providers are gonna use the beefiest GPUs that they can find. So H100s, A100s, if you want to use proprietary hardware from like a cloud provider, AWS's version of TPUs is Trainium, so that's TRN1. So you're going to have your beefiest GPUs or accelerators there. And then as you start thinking about your cluster, what you're now really building is effectively one ginormous GPU across many instances, which means you have to have very fast networking, fast latency, and fast bandwidth. And so in the context of networking, NVIDIA, for example, provides InfiniBand as their recommended solution. AWS has built their own network layer called Elastic Fabric Adapter, which is for H100s, it's 3,200 gigabits per second, for example, on instances. And then the networking layer basically affects your time to train. If you don't have networking layer optimized, you're effectively paying more to train your cluster. And then finally, you see storage. A lot of customers use FSX for Lustre. A lot of customers use S3. A lot of them use EBS, block storage. And then finally, you're going to want an orchestration layer, right? I would say like 2 years ago, customers were using EKS most frequently. Today, pretty much every customer that I work with is using Slurm to interface to their cluster. And for AWS, that's a service called Parallel Cluster, if you're curious. Now, I want to touch on what these instances are capable of and kind of like the scale we're talking about. H100s have basically just released to the world. We're tracking basically 2.5 to 4x higher performance compared to A100s from what we've seen. Networking is very beefy, 3,200 gigabits per second. I think the most interesting part is that these clusters that are built around these H100s are capable of hosting 20,000 GPUs for a given job, right? So that's ridiculously huge. I'll talk a little bit in a second about like how do those numbers affect training jobs, but these are real numbers in terms of like what customers are actually asking for, right? Like customers are actually looking for clusters this large. So we'll see what the world looks like from a model perspective soon, but it's moving very, very quickly. This is kind of what it looks like. This is what it looks like to build a supercomputer, basically, right? You have a lot of H100s talking to each other via very fast networking. They connect to FSX via for storage, and then you have like I mentioned earlier, 3,200 gigabits per second for EFA. And like I said, you're just building a supercomputer here at this point, right? And with this next generation of ultra clusters, which is our basically method of doing networking for clustering, you can host 20,000 H100 GPUs or 30,000 Trainium accelerators. If you're curious about Trainium, it's basically our proprietary ML chip. I would say the biggest thing to know is that it has 512 gigabytes of aggregate memory, and it's designed for LLMs and diffusion models. So they basically optimize it for the generative AI space. I want to talk about a case study, Stability AI. I gave Stability a call yesterday just to make sure I could share all this with you. But I think this is kind of where you can see what the world looks like when folks are building these large foundational models. So today, Stability has for sure over 4,000 A100s. I think the number is probably closer to 6,000 now, but this is what's publicly released. When you have a cluster that large, it's really important that you are keeping your cluster busy, because otherwise it's just opportunity cost, right? So when these foundational model providers get access to GPUs, they typically buy them for a year-long or 3-year-long commitment, which means they are now responsible for keeping those GPUs busy all the time. So what Stability does, as an example, is they have 10 different models training at any given time, right? So they don't just let things sit idle. They have a queuing system that they use to make sure the GPUs are always busy, right? So Stable Diffusion 2.0, which came out end of last year, was one of many models that they were training at the time. That one took 200,000 A100 hours to train. To give you a preview of how Stability set up their cluster, they are using AWS Ultra Cluster with EFA turned on, and they're using Slurm, like I talked about earlier, which is like parallel cluster. Their largest cluster, so this means like one cluster that are all connected on the same spine, lowest latency possible, is 3,384 A100s, which, using that example of Stable Diffusion 2.0 taking 200,000 hours, that would take only 60 hours on that cluster to train, right? So, and if I'm not mistaken, 200,000 A100 hours on one instance would take a couple years to train. So now you understand why these companies have such large appetites for these GPUs, is because time really does matter, right? The quicker they can release these models, the better off they are, and the scale makes a huge difference. Stability just released Stable Diffusion XL, and I asked the team yesterday how long that took to train, and it was roughly 400,000 A100 hours, in case you're curious. All right, so now I'm going to kind of navigate towards fine-tuning. Fine-tuning is really interesting because now you start to talk about Fortune 500 companies. So now we're no longer talking about startups. We're talking about Fortune 500 companies, because these are companies that want to use these models for their own use cases. There's basically 3 categories of concerns, I'll call it, that customers have. The one that comes up really consistently is, hey, what's your equivalent of GPT-4, right? That's a very consistent question that we get asked. And our general answer is Claude. Claude is on AWS. You have access to it, and it works really well. And what's interesting about Claude is that the 100K token size window makes a big difference for a lot of customers. Ease of fine-tuning. This is, I think, just dependent on the customer. But the other consistent thing that we hear is data privacy. Fortune 500 customers do not like it when their data leaves their cloud environment. So even if it doesn't go into the internet, they still don't like it, right? So I'll talk a little bit about that soon. So I'm going to get straight into what are the ways that, I mean, at least AWS is giving access to foundation models to customers. And I'm sure other cloud providers have very similar solutions as well. But I want to use AWS as an example. So the first solution that AWS has is something called Amazon Bedrock. Bedrock is basically AWS is positioning it as the easiest way to build and scale generative AI models using foundation models. It's basically an API that you can use to either do prompting or text embedding or even fine-tuning with a foundation model, right? and it's completely serverless. So what that means is that AWS takes care of the infrastructure management. So for you, it's just an API and it's completely taken care of, right? So today we've partnered with 3 companies on Bedrock. It's Anthropic, AI21, and Stability AI for Bedrock. And then we have Amazon SageMaker Jumpstart. SageMaker Jumpstart is basically more complex to use, but it also gives you a few more knobs to play with. With SageMaker Jumpstart, customers in their own VPC get a SageMaker endpoint that via private link connects to a single tenancy instance in a SageMaker cluster that's hosting the model, which means as a customer, you can't access the weights of that model, but your data is not being shared with any other environment. So it becomes a more secure solution for folks that are more privacy concerned. Additionally, the customer is responsible for managing that infrastructure that hosts that model. So you could decide whether, for example, you want Falcon 40B to be hosted on a G instance or a P instance. And the trade-off would be basically price versus performance, right? Both of these solutions do not share the data with the model providers, but there are, some subtle differences about like how the data kind of navigates in the VPC environment. At a high level, Amazon SageMaker Jumpstart basically lets you prepare the data. It lets you fine tune it and then deploy and monitor it. And these are today the models that are in Jumpstart. It's actually got more models than Bedrock today. So we have Stability AI's SDXL, SD 2.0, we have Falcon 40B, we have all the Hugging Face models, and we actually have models from proprietary providers like Cohere, Lidon, and AI21 Labs. And then, as I mentioned earlier, these are the Bedrock Foundation models, that we have via AWS Bedrock. And then before we get into the discussion, I wanted to just share some random tips that I think would be helpful. If you are looking to build your own very large model, make sure you're checkpointing your training jobs frequently. The more GPUs you have in your clusters, the more important this is. And the reason why is because GPUs tend to have like random failures. It doesn't mean your instance goes bad, but it does mean you have to restart your instance. And when that happens, that will interrupt your job, right? You have to basically restart it. So expect that to happen. And then, for example, I see a lot of customers do checkpointing between like 20 minutes to every hour, right? So just do a lot of checkpointing to do that. If you have concerns about GPU access for things like A100s, I would recommend looking into basically commitments where you can commit to the GPU or GPUs for either 1 year or 3 years. And then you just have to make sure you're utilizing it pretty consistently. Third, focus on price performance at the cluster level is a really strong recommendation that I have. Why is that important? The reason why it's important is because you could look at the specs of a given accelerator, but until you actually test it at the cluster. So I would recommend doing a bake-off between cloud providers or whatever solution provider you're working with. Do a bake-off and then look at the price performance at the cluster level, because that's ultimately what you're paying for. Fourth, I'm sure everyone in this call knows this, but I think this is just an important observation to share. Folks aren't coming to AWS and saying, hey, what are your models on Bedrock? Or what are your models on Jumpstart? They're coming to us and saying, here's my use case. What model do I use? And then how do I consume that model? So just a subtle but important observation that I think it's good to share with anyone in the cloud community. 5, we are starting to see really consistent patterns and use cases, right? I mean, the number of times I've seen a LLM be used with a vector database or something like Kendra is just a lot, right? So right now, what my team is doing is working on blueprints/architectures that achieve probably 80% of a common use case. So then our customer goes and focuses on just doing that remaining 20%. So that's all I had for you. Hopefully that was helpful. And now we can open it up for questions.